Beneath the protective cover and through a microscope, we find the leads attached directly to gold bumps on the bonding pads. This technology eliminates the high inductance created by the thin wire bonds of traditional packaging. Once the chip is cut from its frame, it is carefully aligned for placement. Then, microscopic adjustments are made to ensure the leads line up with the die site bonding pads. A heating plate or thermode solders the extended leads. As the temperature increases, the leads are pushed down into the molten solder. The epoxy beneath the chips is solidified in a furnace, while a specially designed fixture applies pressure to each chip. In a robot work cell, flux is dispensed on the two PowerFlex bonding pads. The power consumed by the multi-chip unit is brought in through a power connector. The PowerFlex circuit, containing 4 copper conductive planes, is aligned with the large PowerFlex pads on the multi-chip unit. Thermode presses against the PowerFlex leads to bring them in contact with the pad. As the heat increases, the solder on the MCU pad reflows and the bond is complete. The process is repeated with the second connector on the opposite side. Flux is now dispensed on all 4 SignalFlex bonding pads. Each one of the 4 signal pads contains 269 etched lines or leads. SignalFlex connectors, consisting of 2 metal printed layers, transmit the signal between the high-density signal carrier and the planar module. Again, a thermode applies pressure and heat to bond the SignalFlex connector leads to the SignalFlex pad. Each one of these raised gold bumps connects to a signal lead on a chip. After washing and assembly, the raised gold bumps face upward. Near the clock chip, a unique serial number is encrypted by interconnecting special pads. Using this number, a computer, if necessary, can review the manufacturing history of the MCU without having to remove it. After extensive testing, a lid is placed on the MCU to protect it from mechanical damage. Finally, a pin fin is attached to the back side of the signal carrier. Much like our own bodies, the faster a chip runs, the more heat it releases. When these high-powered chips are operating, air is blown through the pins to dissipate the heat. These multi-chip units go on to be assembled into the planar modules used by this high-end computer. Producing computers requires many manufacturing industries and research from a wide variety of academic disciplines. Regardless of the type of computer or electronic product, they all require integrated circuits, which in turn rely on computers for their design and manufacture. Today, it takes computers to make computers. And of course, a highly trained workforce to tell them how to do it and supervise the process.